Hello friends, myself Rahul Tiwari and I am a B.Tech civil engineer. So today we will learn about how to calculate of cement, sand and aggregate. It is the first step that we have to do to choose our grade of concrete. Which grade we want to calculate, in which grade we wanted to calculate the grade of the concrete. So the first step to choose a grade of concrete. For example, I have given in the slides as I have taken M20 grade and the ratio of the M20 is 1 ratio 1.5 ratio 3. So 1 is cement and the middle one 1.5 is sand and 3 is aggregate. The second step, choose a quantity of a concrete. Choose a quantity of concrete, that means how much you want to, for how much concrete you want to calculate the quantity. For 1 cubic meter, 2 cubic meter, anything you can take it. So for example, I have taken 1 cubic meter. And then step 3 is concrete quantity. See, whatever concrete we use on the site, that is a wet concrete. So the 1 cubic meter is a wet concrete. So to convert it into the dry concrete, we have to multiply with 1.54. This is a standard factor that we have taken in this industry. So that is a 1.54. We have multiplied with 1.5. That means the dry quantity of concrete is 1.5 cubic meter. And the step 4, now we have to calculate the dry quantity of the cement, sand and aggregate. So when we calculate the quantity, we use in a dry form. We purchase in a dry form. So that is why we have converted into the dry quantity. Then the example is given 1.54 into 1 upon 5.5. So we are calculating the cement quantity. So that's why we have divided 1.54 into 1 upon 5.5 from the M20 grade. We are multiplying by 1.5 because the cement is one part of the total quantity. So that is why we are multiplying with 1 upon 5.5. So that what comes is 0.28 cubic meter comes after dividing 1 upon 5.5 multiplied by 1.54. Okay, now we will move to the next slides. Yeah, so 0.28 cubic meter is the part cement is in 1 cubic meter. So now we have to convert the volume into kgs. So this is the volume that comes. Now we have to, when the bags comes in kg or bags, otherwise whenever we go to the shop to purchase a cement, it comes generally in bags or in kgs. So the density, to calculate this quantity, we have to multiply with a formula that we all know, we have studies from our childhood, that density is equal to weight upon volume. So density of the cement, that is a standard density 1440 kg per meter cube, and by multiplying density into volume we can get the weight. So the density is 1440 multiplied by 0.28 is equal to 403.2 kgs. If we convert, that is a 50 kg. So 403.2 divided by 50, that is also approximately 8 bags comes. So in 1 cubic meter 8 bags of cement bag is needed. So we will next move to calculate the sands. We talk about the sand quantity. How we will calculate the sand quantity in 1 cubic meter? Example, I have taken ratio of sand is 1.5 upon 5.5 and then multiply with the dry factor to convert into dry volume 0.42. The same formula as we have used in previous slides, that is 0.42 into 1600 volume into density 672 kg per meter cube. The density of a dry sand standard is 1600 kg per meter cube. To convert, whenever we go to the shop, we don't ask with a vendor to give us 672 kgs per meter cube. He didn't give us in kgs. We don't purchase sands in kgs. We purchase in a cubic feet. So to convert a meter cube into cubic feet, we multiply with 35.31. So it's equal to 14.83 the cubic feet of the cement. Sand is calculated upon 5.5. 0.545 multiplied by 1.54 is equal to 0.84. The same as the previous one. The density of the aggregate is taken 2400. So it varies from 2400 to 2900 kg per meter cube. I have taken here is 2400, then multiplied with 2450 is equal to 2058 kgs comes. In cubic feet, 0.84 multiplied by 35.31 is equal to 30 cubic feet comes. One of the most important concept that we all miss is water cement ratio. How much water is needed? So I have referred here IS 456 table number 5, minimum cement content and maximum water cement ratio. Maximum water cement ratio, after that water we don't mix any other water. Okay, so the water cement ratio, we have to know the water cement ratio. What is the water cement ratio? For example, maximum water cement ratio is given for M20 grade is 0.55. For example, I have taken the cement of 400 kg to calculate in a 400 kg of cement how much water I needed. So water is upon cement is equal to 0.55. The water cement ratio is given. Water upon cement content is already defined is 400 kg is equal to 0.55. Now we'll do the cross multiplication. 0.55 into multiply by 400 kg is equal to 220 kgs. So 220 kgs, we all know that 1 kg is equal to 1 liter. So 220 is the maximum water that will mix in 400 kgs of the cement. We discussed aggregate, water, cement and sand quantity and water also. So now we will do some practice session. First question is come in front of your screen is how many cement bags need in 5 cubic meter of M20 grade of concrete. So calculate. I'm giving you some time. 41 bags of cements we need. And now the next is if water cement ratio is 0.45, how much water is required for 4 kg of cement. So the first 70 liter, B is 50 liter, C is 60 liter and C is 90 liters. So the right answer is 90 liters. So thank you very much for watching.